Okay, so we've talked about polar coordinates and rectangular coordinates, and now we're going to kind of go back and forth between the two with our conversions. And so we're going to be able to kind of take something that's polar or rectangular and go the other way. So the key picture with all of this is how these two relate to each other. So we're used to, for rectangular, we go over x and we go up y. That's the point x, y. For polar, what we see is we go out a distance and we rotate an angle. And so we use our ideas of trigonometry to relate these. And so I know that if I'm looking for an x value, right, in regards to theta, that's my adjacent piece, and y is the opposite piece, and r is my hypotenuse. And so if I was to look at cosine of theta, so cosine of theta is adjacent over hypotenuse, x over r, and then sine of theta is opposite over hypotenuse, y over r. And if I just solve for r, multiply by r, I get x cosine theta, r cosine theta is x, and then y is r sine of theta. And so that's going to allow me to convert between x and y. And then if I was looking at theta, right, I know that tangent of theta is opposite over adjacent, y over x. And so that's really all these conversion factors up here doing, is it's using your basic trigonometry and just solving it for a right triangle. And so using that, we can relate them and go back and forth, and we'll look at some examples of how that works here in a second. So we have a rectangular coordinate. We have d and pi over 3. And so what that means is that I've gone from my polar axis, I've gone out a distance of 2, and I've gone up pi over 3. And what I'm trying to do is I have that point. I'm trying to relate it to x and y, which is over and up, x and y. And that makes a right triangle. So we just use our properties of r and theta for r cosine theta and r sine theta. And we use the our unit circle values of cosine of pi over 3 is 1/2, and then sine of pi over 3 is root 3 over 2. And when we simplify, we get 1 and root 3, which means that this point is over 1 and up root 3 in terms of x and y. And so that's going to give us values for x and y that we can use. So we've converted it from polar to comma pi over 3, which is an r theta value, to our horizontal and vertical pieces, which is x and y. And we just have different variations on how that looks. So those are ordered pair. That's what we just looked at, and we get our piece. All right. Same idea here. I have a -5 and I have 45 degrees. One thing, if we're thinking about it as a picture, I need to be a little bit careful of what this does here. So I know that if I was to graph this, I have a distance of 5. Here's 45 degrees, right, is that rotation. Since it's a -5, what I'm going to do is my 5 is over here. And so my angle of 45 degrees is right here. And if I really want to solve for it, the theta that will give me the right signs for x and y has to be 180 plus 45. Okay? And then 180 plus 45 is going to give us the values in terms of where we are. So 180 plus 45 is 225. So I can use that angle measure to figure out what those values are. All right. I also have my r value. If I just want to plug into their formula, I have the -5 times cosine of 45, and then the -5 times sine of 45. And that will take care of my whether they're positive or negative as well. So whether you think about it and translate it directly, so figuring out the angle and knowing where it is, or if you just use the value that's on your the r value, it'll work for you. Now, if you remember your quadrants, right? So in the first one, it's positive, positive, and then this is negative, positive, and then it's negative, negative, and then it is positive, negative. And we know that this first one, the x value, is our cosine, and then the second one is our sine. So those will allow us to, if we just use our sine and cosine values with the right r value, it'll give us the right sign. Right. All right, and that's again the picture that we looked at. We can see down here we get our coordinates are negative, negative, which we knew they had to be. This is our exact form. If we plug it into a calculator, we get an approximate form. All right. I want to find the rectangular coordinates for h, negative 240. Again, you can just directly use your values for you have r of 4. So r is 4, and then theta is negative 240. Or if you want to look at it visually, right, here's negative 180. And then to get to negative 240, it's another distance there, where I have a distance of, what is that, 60? And I've gone out a distance of 4. So if you want to think about your components that way, and get your x and y values, you can, or if you want to just plug it into the conversion formulas, you can to get the same answers in the end. All right, they're using the conversion formulas. They're using r cosine theta and r sine theta to relate them, where theta is negative 240. We'll plug through it, we get our value. And there's the picture that we drew. Our final piece, again, is negative positive, which we knew it had to be negative x, positive y as our coordinate. So you need to try this one on your own on your handout. You have the rectangular coordinates of negative, find the rectangular coordinates given the polar coordinates of negative 8 and 300. Okay. So we want to look at this in terms of if we have a rectangular coordinates and we're going to polar coordinates. So this first part is, again, a right triangle, how we're relating the two. And so I have this, from the Pythagorean theorem, r squared equals x squared plus y squared, or r is the square root of x squared plus y squared. It's going to give me a value. And then theta, again, is, since y is opposite and x is adjacent, we know that tangent of theta equals y over x. So theta is tangent inverse of y over x. That gives us a value that we can use. So we can take our x and y values and determine r and theta with those two properties. All right. So the difference, one of the differences with polar versus rectangular is that we have multiple ways to get a polar coordinate, since we can add or subtract rotations of 360 degrees or 2 pi. And so given a unique xy value, -2, negative 4, right, we can find r and theta by using what we just did before. R is x squared plus y squared, and theta is the tangent inverse of that ratio. And we get our value. Now that's only one value for theta. We could do a add 360, subtract 360. We could also flip r around. Instead of being positive 20, it could be negative 20. So there's going to be multiple ways that we can find coordinates for polar, which is why in this case it specifies that we want 2. All right, so there's again our picture, and then we can just have, we can add or subtract those values of rotations to get our other points. All right, same idea here. Again, you're using r is, with our Pythagorean theorem, right, where we have those values that are moving, and then we have theta using a tangent inverse. And when we do that, we're going to see that we have, again, 2 pairs that we can find using rotations of those. All right, and then again, we get those values. As we're looking through it, really just looking at going around or backwards to get to the same angle measure. All right, you need to try this one. I would suggest that you plot it first. So you're going to go back 5 and down 6. So you should be in that third quadrant. Find your distance using the Pythagorean theorem, and then use a tangent inverse to find your angle, and then add or subtract multiples of that to get other angles. All right. Now we're looking at equations. Okay, it's the same idea where we have the ability to rate them. We have to do some algebra to kind of combine them. What we want to do is first off figure out what we're talking about with this graph. So since I have 2 things that are added together, I could rewrite this in the form that we're kind of more familiar with, where I take this, and if I divide everything by 4, I get x plus 2 squared over 4 plus y squared over 4 equals 1. These values on the bottom are the same, which means it's going to be a circle. And so this is going to look like a circle. What I want to do then is make a conversion. So I don't want it in terms of x and y, I want it in terms of r and theta. We use the same thing where r cosine theta is x and r sine theta is y. and we drop those in. So I get, for x, I'm going to get r cosine theta plus 2 squared, and then plus r sine theta squared is equal to 4. That's our setup. And now we just have to plug through our math here to make this work. One thing to be careful of is you cannot just distribute your squared. What you have to do is write out what this looks like. So r cosine theta plus 2, and then r cosine theta plus 2. When you expand that out, you cannot just distribute that piece. So they're going to go through those mechanics. Using that first substitution is really the hard part of making sure you have those pieces in the right way. So what we see is that we're going to simplify those. That's our original equation. They drop in what we just did, and then they have to do some math. So this piece here is the expansion when we multiply that out. And now what we're going to do is collect our like terms. So what we see is we have r squared on both of these. So we bring those two together, and then we're going to subtract our value across. So we're going to subtract minus 4r cosine theta. We factor out an r squared, and I'm left with cosine squared theta plus sine squared theta, which is our Pythagorean identity, which is equal to 1. So I get r squared, right, equals negative 4r cosine theta. And then if I divide by r squared divided by r is r, and that goes away, and I'm left with this piece. So r equals negative 4 cosine theta. That should be, again, a circle, as we knew it had to be from our rectangular conversion. When we look at the graph, we see that we get a circle that is shifted to the left by 2 in the x direction, which is what we saw with our rectangular coordinates. Okay, we're going to look at this one and see kind of what this looks like. So if I was to take our starting point and write it in terms of y, so divide by 2x equals 4 over 2x, I get 2 over x, and this is going to be a hyperbola. I'm going to have I'm going to have an asymptote, a vertical asymptote at 0. I can't plug in 0, and I'm going to get my graph that looks like this, where I have those horizontal asymptotes where it's going to 0 as x gets really, really big. So again, though, to convert this, we're going to use our values where it's 2 times r cosine theta is x, and then times r sine theta is y, and that's still equal to our value of 4. So they're going to plug those values in and then simplify to see if there's things that drop out that make it easier to look at. So again, they make their substitution, right? Multiply it through, and then we get 2r squared is cosine theta times sine theta, and then we can simplify that. So r squared is 4 over 2 cosine theta sine theta. This is hard to see, but this is our double angle identity for sine. So 2 cosine theta sine theta is going to reduce into sine of 2 theta. And then when we have the reciprocal, so something over sine, that is cosecant. So this is our final answer. If you get to this point, then that's probably fine as well, if you don't see that it's the double angle identity for sine. If we were to graph it in polar form, we would get the same graph that we got when we did it in rectangular. All right, you need to identify this graph, looking at there's only one squared term, so think about what that shape would look like. Use your values for x being r cosine theta and y being r sine theta to make your conversion and see that you should get a parabola. All right. This is going the other way around. All right, so I have a rectangle. I want to get it into x and y where I'm just given r and theta. This one is where I just have an angle to start with. If we think about what that's going to look like for my angle, right? I have pi over 4. Theta is pi over 4, and if this is r, pi over 4 is going to look like that. That's pi over 4. So I should get a line. If I'm doing that, I know that tangent of theta, I can take tangent on both sides. Okay, so tangent of pi over 4, those are the same, sine and cosine are the same, so that is just 1, which is what they're showing there. And then I know that tangent of theta is y over x, and I know that if I just multiply by x, I get a line like we'd expect.